Good morning, grade 10. I'm going to go over the answer key for the slope practice I had given you and the other activity that was board work. And then I'm going to assign the targets for RF5. Okay, so let's get started. Okay, so the first one says to find the slope of each line. So the way that we're going to do that is remembering that the formula for slope is to take the rise over the run, and whenever we have a graph where we can actually count, it's easiest just to do that. Remember, always start on the left hand side, so this dot to this dot. So what's happening here is this is going down. This is my rise. Up and down is the rise part. So it's going down 1 and it's going across 1, 2, 3. So the slope is a negative 1/3. Okay. Number 2, again, start on the dot that's on the far left. Okay, so it's going up 1, 2, 3, and it's going across 1. Okay, so that has a slope of 3/1, or you could just say 3, because of course anything that's has a 1 on the bottom is still just 3. Okay, this one, down 1, 2, 3 over 1, 2. So down 3 over 2. This one is up 1, 2, 3 over 1, 2. Number 5, up 1, 2, 3, 4, 5 over 1, 2, 3. 1, 2, 3, 4, 5 over 1, 2, 3. Okay, always doing how it's changing vertically first versus how it's changing horizontally second. That goes on the bottom. Okay, always, always. Number 6, it's going up 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. 7 over 3. And if ever we got to one that we could reduce, then we would. Okay, but so far we haven't found one. And then number 7, down 1, 2, 3, 4, 5, 6 over 1, 2. And that's an example of one right there. And so here's an interesting thing that that happens is that because this is a line, a straight line, then watch when this reduces down. You could divide both of them by 2, so it would become 3/1. Watch what happens when I go down 3. 1, 2, 3, and over 1. Look, there's another point on the line. So that's a question that you might get asked sometimes, is give another point on the line. And the other, likewise, I could go like this. I could go, even though it's a negative 6/2 or a negative 3/1, don't forget that this is also the same thing. So 3 over negative 1. So I could go up 3, 1, 2, 3, and backwards 1. And so there's another point, right? And you could keep doing that. There would be infinite number of points on this line. You could go down 3/1, down 3/1. Keep going. Okay. And this one right here, up 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Up 7. 1, 2, 3, 4, 5, 6, 7 over 3. So this line right here has the same slope as this line right here. But what's different about them is that they have different y-intercepts. This has got a y-intercept of 3, positive 3, and this one would have a y-intercept of something like negative 1, 2, 3, 4, 5, probably. Negative 5, maybe? Somewhere right around there. Okay. All right, so that's your answer key to the first page. So now we're looking at how to find the slope when they just give us the 2 points. And I said to you last week when you were doing this that if you wanted to, you could actually take a piece of graph paper and put those points on the graph paper. So I'm just going to show you how to do that. So if you take your graph paper, and I'm going to make this kind of somewhat large. So we've got a Cartesian plane here, which is your y-axis intercepting your x-axis. The y-axis is, of course, the one that goes vertically. The x-axis is the one that goes horizontally. And so this says the 2 points are 8 and 10. So that's our first one, 8, 10. So we're going to find that. So 8 is at 1, 2, 3, 4, 5, 6, 7, 8. And then 10 on the y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's that point, the first one that they gave us. And the second one is at negative 7 and 14. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, negative 7. And 14 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is my 8 and 10. And here is my negative 7 and 14. Keeping in mind the first value is always my x. The second value is always my y. Okay? After you have those two dots, then you can connect the dots. Okay, so here's our line that we're talking about. Okay, and then, of course, I'm going to put arrows on this because it doesn't tell us whether it's a line segment or a line. Line segments end and lines continue on. But it wants us to say what is the slope. Okay, so when I look at this, I'm going to go, okay, how is it changing from that point down to this point? And of course, we always start on the left. Okay, so we're going to go like this. So we're going to down 1, 2, and I'm going to use a different color just so it will stand out for you a little bit. So it's going to go down 1, 2, 3, 4. That's a change of going down 4. And then it's going to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's an increase of 15. Okay? Let's just see. We've got that right here. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that means that my slope is down 4 over 15. Okay? And so that's one way to do it. But the other way to do it would be to just, I'm going to zoom back in here a little bit. We're just going to look at this and we're going to say, okay, so if this is my y, and this is my y, how is my y changing? Okay, so from a 10 to a 14, that's an increase of 4. And then from an 8 down to a negative 7, that's a decrease in 15. Okay, which is the same thing as to say negative 4 over positive 15, because of course those are equivalent to each other. Okay, so how is it changing on my y? It went from a 10 to a 14, that's an increase of 4. And from an 8 down to a negative 7, you get a picture in your mind, a number line. From a positive 8 down to a negative 7, that's a decrease in 15. Okay, so when I look at it this way, that's the same answer as what I got over here. It's probably a lot faster for us to just count it on here, seeing how it's changing, as opposed to drawing them all out. But if you get stuck, then you can do that, okay? So remember to start here with my y's, because we're talking about how is it changing on my y over how is it changing on my x. Okay, so my y is changing from a 1 to a 2. That's an increase of 1. And from a negative 3 to a negative 17, that's going down 14. Okay, so you can put the positive on the top or negative on the bottom, doesn't matter, or you can put it like this. These mean the same thing. They mean the same thing. Okay, next one. So from the 4 to a negative 10, so how is it changing on my y? How is it changing on my x? From a negative 4 down to a negative 10, that's a decrease in 6. And from a negative 20 to a negative 12, that's an increase of 8. And so that would reduce to a negative 3 over 4. Okay, next one. It's changing from a -5 to a -8. It's going down 3. And then from a -12 up to a 0 is an increase of 12, which reduces to a 1/4, and it's a negative. Again, you have to picture a number line in order to be able to do it. Okay, from a -6 to a +16 is an increase of 22. And then from a -19 to a +15 is an increase in 34. And that would reduce to, you could divide them both by 2, and you'd end up with an 11/17, which is reduced. From a 9 to a -9 is a decrease in 18. And from a -6 to a +7 is an increase in 13. Doesn't reduce. And then from a -20 to a -15 is an increase in 5. And from a -18 to a -18 is not an increase at all. It's a 0. So what did I say to you the other day? If it doesn't change on my it doesn't change on my x, but it only changes on my y, what is that going to look like? So is that going to be a vertical line, or is that going to be a horizontal line? So let's just take a second, a little side step here for just a minute and have a look at these and see what we mean. So if we have one that is going to be increasing, let's just say it was starting here, just for argument's sake, and it was going to increase by 5 on the rise, so 1, 2, 3, 4, 5, but it had 0 run, so it didn't move across at all. It didn't move across at all. Then what we have is a line that goes straight up and down. And what did we say this kind of a slope is? This is known as an undefined slope. And basically what it means, undefined, is that it's an impossible slope. You would need like rappelling gear in order to be able to climb something like this. This is like, you know, El Capitan kind of stuff. Have you watched that on Netflix? That's that kind of slope where you've got no run but only rise. You know, you're a mountain climber. Okay, over here, this one, as a if I show you this one right here, this has no change. Let's again start here. So it's not rising at all, 0 rise, but then it's running across 1, 2, 3, 4, 5. This is something that even I can do. This is like walking, you know, on a straight horizontal line. There's no incline, no decline at all. This is, you know, this is easy. So we actually call this a 0 slope. Okay, so just a quick little reminder of that. So when I look back at this question right here, and I have 5 over 0, this is actually considered an undefined slope. And then the last one, again, from a -18 to a +12, is going to be an increase in 30. Oh, there's the bell. Do you mess the bells? I bet you don't. All right, and then from a 12 down to an 11 is going down 1. Okay, so we have a -30 is how you would write that as your slope. Okay, so let's keep going, and we'll move on to that section that was called your board work. So grab that part, please. Okay, so the board work said that it wanted you to create a graph of the following properties. You may use the same Cartesian plane, however, label each line with its own slope. I have this neat graph paper that has like 6 little Cartesian planes on the same page. So I'm going to do mine separately. I'm going to just kind of zoom in. And what I'm going to tell you is that I'm going to assume that each little line is worth 1. Okay, so I'm not going to label all of the axes. Each one of these is going to be worth 1. And that's not always the case. But if they don't label it, then the assumption is that it is worth, each line is worth 1. Okay, so So we always start with the y-intercept, and so it said the y-intercept was a -1, so I'm going to put that as my first point. Okay, I kind of need a point and I need the slope in order to be able to draw the line, or I need 2 points, one or the other. So I have a point, which is the y-intercept at -1, and then I have a slope. Remembering that the number on the top is my rise and the number on the bottom is my run. So it's going to go up 1 and then over 4. Up 1, over 4. 1, 2, 3, 4. There's my next point. I can do a few of these. Up 1, over 4. I could also go backwards 1. So down 1 and backwards 4. So down 1, backwards 4. And why is that so? Because a -1 over a -4 is still going to end up having the same, it's going to reduce to the same thing as a +1 over 4, because 2 negatives make a positive. So that's why you can do it that way. So you could go down 1 and backwards 4 as well, and you end up on the same line. Okay, so once I have a few points, I'm going to connect the dots. Okay, and so there you have number 1, or A, excuse me, B. So we have a slope of +3, 1, 1, 2, 3. This is a y-intercept, excuse me, of +3. And then a slope of -2 over 5. So down 2, 1, 2 over 5. 1, 2, 3, 4, 5. So I hope you're picking up on the fact that if you have a negative, then you're going down on your y-axis. If you had a negative down here, then you would be going backwards to the left. But because the negative is only on the top in this particular case, then we're going to go down 2, but to the right 5. Down 2, 1, 2, to the right 5. 1, 2, 3, 4, 5. Or I could also, keeping in mind that I have a 2 over -5, means the same thing. I could go up 2 and backwards 5. So up 2, 1, 2, 1, 2, 3, 4, 5, and look how that's going to be on the same line. I use that trick a lot if I run out of room, like I did right here. I can't keep going down, so then I use that trick to go backwards because it's going to get me a dot on the same line, and that just makes it easier for me to use that same little Cartesian plane. Okay, next one. I have a y-intercept of -4, 1, 2, 3, 4. And then I have a slope of up 4 and over 3. Up 4 over 3. Up 4 over 3. 1, 2, 3, 4, 1, 2, 3. And you know what? When you put your dots, if you end up with one that is kind of off the line a little bit, you know you made a mistake, because these are all linear. They're all nice and straight lines, okay? So they should all end up like that. Nice and straight line. Okay, next one. +2 is my y-intercept, and then down 2 and over 1. And you say, well, where's the over 1? Anytime you have no number on the bottom, you know it's a 1. Down 2 over 1. Down 2 over 1. Look at how steep that slope is. That would be quite the incline, wouldn't it? Or decline, I should say. Next one. Now this one's a little bit weird. It's at a 1.5. So there's 1.5. Okay, and then it's going to go up 1 from that point. Up 1, so up 1, and then over 3. 1, 2, 3. Now, these ones are a little tricky. So you're going up 1. So see how that was halfway through. Up 1 over 1, 2, 3. Now what you could have done also is you could have made each of these worth a half if you wanted to. So if I wanted to do it that way, might make it a little easier. So I'll do that one here. That might make it a little bit easier for you. So if we have it at a y-intercept of 1.5, and we have the slope of 1/3, instead of making these worth 1, I'm going to make them that each one worth, so this is 1, 2, 3, 4, 5, -1, -2, 3, 4. I'm doing the same going this direction as well. So 1, 2, 3, 4, 5, -1, -2, -3, -4. And then this one will be a little easier because I can find the 1.5 is right here. And now I'm going to go up 1. So up 1 over 3. 1, 2, 3. Okay. All right. So there you have what you could do if you got stuck. Okay, so let's look at F. So if we have a y-intercept of 8, so positive 1, 2, 3, 4, 5, 6, 7, 8. And then now we have a slope of down 3 over 7. So down 3, always from that starting place. You need a starting place. So down 3, 1, 2, 3, over to the right 7. 1, 2, 3, 4, 5, 6, 7. We really only need 2 points in order to be able to connect the dots, right? 2 points is really your bare minimum. Okay. All right. Now, what if you've been given an x-intercept and a y-intercept, and then they want you to find the slope? Well, the x-intercept is where it crosses my x-axis, and so this is a -2, so there's my x-intercept. And then my y-intercept is the positive 5 where it crosses my y-axis, so 1, 2, 3, 4, 5. Once I have 2 points, then I am able to figure out what my slope is. So connect those dots, okay, and then just count it. Up 1, 2, 3, 4, 5 over 1, 2. So I always do the rise, how it changes on my y over how it changes on my x. And so it's going to go up 5 over 2. Positive 5 over 2. And then next one. So this one has an x-intercept of positive 6. 1, 2, 3, 4, 5, 6. And then it has a y-intercept of -8. 1, 2, 3, 4, 5, 6, 7, 8. Connect the dots. Sorry about that, I got interrupted. All right, so the slope is that it's going up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6. Increase of 8, increase of 6, which would reduce to a 4 over 3. Okay, next one, y-intercept of -4, y-intercept of -3, connect the dots. How is it changing? It's going down 1, 2, 3, 1, 2, 3 over 1, 2, 3, 4. So down 3 over 4. That's my slope. And then this one, the x-intercept is at the positive 4. The y-intercept is at the positive 3. Okay. Okay, down 3 over 4. So these two right here, this last one, they have the exact same slope. And just notice them. They look the exact same in terms of how steep they are. Okay, even though they have different intercepts. Okay, then the -7, 1, 2, 3, 4, 5, 6, 7. -9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Connect the dots. That's right. So he's going down 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 9. And then to the right 7. That one doesn't reduce. And then the last one is at the 3.5 on the x, so 1, 2, 3.5. And then on the y, it's at the 5. 1, 2, 3, 4, 5. So how is it increasing? It's going up 1, 2, 3, 4, 5. And it's going across 3.5. Which, of course, we would normally not put a decimal like that. So let's change that into a 10 over 6. What did I do? I just times them both by 2. 10 over 6. And then you have nice whole numbers. Oh, it's not 6, it's 7. Good land. Sorry about that. 7. Okay. And so there you have the answers to all of your questions.